Okay, so section 1.5 is about getting an answer of an infinity for a limit. So we want to kind of analyze something like this. So I'll give you a second. Go ahead and just feel free to pause the video when you need to write down something that I have on here, and then we can pick up where we left off. Okay, so go ahead and get the thought bubble down. So I want you to think about what happens when you have f of x equal to 1 over x. And kind of the way that we would do this in the past, right, is that we would... we can't factor it, right? We can't. There's no conjugate we can use or anything like that. So we're probably going to have to do this by a table or a graph. You probably know what this looks like, and you could do it graphically. So we're going to think about what would the limit be as x approaches 0 for this function. Okay, that's the problem that we're trying to solve. And so in order to do that, we would have to go ahead and look at tables like this. Okay, now think about why I put these in fraction form, right? If I put negative 0.1 here, and I have to plug that in to the function to try to get the y value out, negative 0.1 isn't very helpful because it's rational. And I know that if I take negative 0.1 and turn it into a fraction like this, when I go ahead and plug that in here, well, that's pretty easy to do. I'm just basically taking the reciprocal of negative 1/10, right? And I know that in that case I get negative 10. Okay, and then if I take the reciprocal here, and then lastly down here. So I can see that the trend as I approach 0 from the left-hand side, right, is to get very negative. As I get closer and closer to 0 here, these numbers get larger and larger and larger. Okay, consequently, if I'm looking on the right-hand side, look what happens, right? I'm just doing evaluations in 1 over x, so 1/10 is 10, and I have 100, and then I have 1,000. So as I approach 0 closer and closer and closer here on the x side of things, the y side of things tend to get really large. Okay, and so of course it seems, of course, that I have this disagreement, right, between how positive answers and positive answers and negative answers over here, and the fact that they disagree, right, leads me to write does not exist for this limit. Okay, so you can analyze rational functions such as this via tables, but we're going to hopefully by the end of this talk about why you wouldn't want to do that. Okay, so we have this here. It says when y values tend to get really big in either the positive or negative direction, what occurs? So think about the function 1 over x, right? What's going on in that function typically? Can you draw it? Okay, hopefully this is one of those functions that you kind of have memorized, and you know that it would be in this quadrant here, and then it would be in this quadrant down here, right? And so of course at 0 we have this vertical asymptote, right? And since we have an asymptote that occurs there, usually that means that we're going to write does not exist, specifically in this case because one heads upward and one heads downward. Okay. However, I can also have asymptotes where other things happen, right? I have these 3 cases down here. Again, feel free to pause the video if you want to, sketch any part of this. So the first case is when, let's say I'm trying to find the limit here as x approaches 0 of this function. This is essentially 1 over x squared. Okay, it turns out that they are both heading in the same direction, right? And because they're heading in the same direction, I'm not going to ask you to write does not exist. I want you to make sure that you write positive infinity for your answer there. Okay, likewise in the next example, if you go ahead and sketch that, right? I'm going to ask that you write negative infinity because both, as you approach 0 from the left and right, they both go off towards negative infinity. Okay, and then lastly over here, this is kind of a negative 1 over x. When the one goes up and one goes down, just like the first example, that's when we're going to go ahead and write does not exist. Okay, so that's kind of a new thing. I still need you to understand that the limit does not exist in these cases either because it's not a number that we're writing down. It's just a direction that we're giving as our answer. But there is an expectation that you will denote which direction it's heading in with these infinities. Okay. Other examples that we're going to start to do with this, going on to the next page here, we've got limit as x approaches 0 from the right of 1 over x squared. So let's just say you'd be given any one of these questions here, and let's just start with example 1. Okay, well, if I'm trying to analyze 0 from the right and 1 over x squared, there's some things that I want to start to think about, right? I know, because I can't factor this, I can't mess with it, I know this function has an asymptote at 0, right? And that's something that knowing more about functions and their behavior really helps you, to kind of know very quickly. Okay, since I know that there's an asymptote at 0, when I'm on the right side, I could go ahead and make a table of values for this on the right side of 0. And because it's, rational like this, I would probably do 1/10, 1 100th, and 1 1,000th again. But truth be told, right, if I know that there's an asymptote there, do I really have to plug in these small of values and try to figure out whether, how big the answer is getting? The answer is no. As long as I just if I know there's not another asymptote in the problem, I can pick any positive number on the right side of 0, and that will tell me whether that is approaching positive or negative infinity, right? So if I pick, let's say if I just pick the number 1, right? And I think in my head, I think about 1 over 1 squared, because that's the function 1 over x squared. I get a positive answer. That tells me that this is going to be positive infinity. Okay? And then think about 1 over x squared here. I could plug in these really small numbers, negative 1/10th, negative 1 100th, negative 1 1,000th. But it's not like the magnitude, the number that's going to help me get this answer. I just need to know whether that asymptote, whether that function is heading up towards that asymptote or if it's coming down towards the asymptote, right? So now if I take a negative number such as negative 1 and I simply input that here, right? Negative 1 squared is still positive, so this is essentially a positive number as well. So that's why I'm going to write positive infinity down. And then to do this final one, I would just go ahead and notice that these guys match and write positive infinity. Okay? All right. Moving on, last one here. Not a ton of examples today, but let's look at something a little bit more involved, like 5 over x minus 3. Okay? Again, you can make a table of values. I'm going to encourage you not to. You know that you can't factor this, right? You know it's not a whole that's happening at 3. You know that it's an asymptote. So your job, right, is to figure out, well, is this function at x equals 3, is it going up like this, down like this, or whatever, right? And you can go ahead and simply plug in a number to figure that out. So, the best thing to do is to pick a number really close to 3, right? You don't want to get too far away from it. So if I'm right next to it, and let's say I pick 3 on the left side, I would pick 2.9. So I'm going to think, in order to solve this problem, I'm going to do 5 over 2.9 minus 3. And since that denominator ends up being negative, I have 5 divided by a negative number, which is a negative answer. So this is going to be negative infinity. Okay, likewise here on the right side of 3, I am going to just, of course, pick 3.1 to plug in and think about 5 divided by 3.1 minus 3. Well, it turns out my denominator is positive, and when I take 5 and divide that by a positive, I further get a positive answer, right? And so I'm going to go ahead and think that's enough information to give me positive infinity here. And now to do the last one, when x approaches 3, right, I have to consider the left and right-hand limits together. Since they disagree, I'm sure you can figure out what to write down there. Okay, and then that is the final answer for that problem. So this is this little shortcut method is really advised when you know that there's an asymptote on a function, right? You can just do kind of almost like a little sign evaluation, SIGN sign. Okay.